Let us discuss how to determine if a surface parameterization is smooth. In this case, we will examine the function r of t over the given ranges for u and v. If the surface parameterization r of t is smooth, then r prime will not equal 0 in the given ranges, and it will be continuous. R prime is the cross product of each derivative. Therefore, we must find r sub u and r sub v. Starting with r of t, we will take the derivative with respect to u and find r sub u. R sub u is equal to v squared 1, 0. Then we will take the derivative of r of t with respect to v to find r sub v. R sub v is equal to 2uv, negative 1, cosine of v. Now that we have two derivatives of the surface R, we can take the cross product of them. Arranging the vector components gives us this matrix, which has I v squared 2uv, j 1, negative 1, and k 0 cosine of v. After taking the cross product, we are left with cosine v, negative v squared cosine v, negative v squared minus 2uv. Since r prime is equal to the cross product, we can set the result equal to r prime. Now we must check if r prime is continuous and not equal to 0. Note that each component is a continuous function, the addition of continuous functions, or the multiplication of continuous functions. Therefore, the entire function must be continuous. Looking at the I component, the only value in the ranges that would result in a 0 would be v equals pi over 2. But if v equals pi over 2 is substituted into the k component, that component cannot be 0 within the given ranges. Since at least one component is always non-zero, r prime is never equal to 0. Because both conditions are satisfied, the surface parameterization of R is smooth.